Hello everyone. My name is Shreyan Sanyal and the registration number is 20BCE0852. Today we will be discussing about photodiodes. Before starting photodiode, we must know what is an optoelectronic device. So optoelectronic device is a device which converts optical signal to electrical signal or electrical signal to optical signal. In other words, it's optical to electrical or electrical to optical transducers. Now, photodiode is an optoelectronic device. A photodiode is a PN junction or PIN semiconductor device that consumes light energy to generate electric current. It is also sometimes referred as the photodetectors. There are two types of photodiodes, PN junction photodiode and PIN junction photodiode. Today we will be discussing about PN junction photodiode in this particular video. Photodiodes are specially designed to operate in reverse bias conditions. Reverse bias conditions mean the P side of the photodiode is connected to the negative terminal of the battery and N side is connected to the positive terminal of the battery. Now, we will be discussing about the PN junction photodiode. When external light energy is supplied to the PN junction photodiode, the valence electron in the depletion region gains energy. If the light energy applied to the photodiode is greater the band gap of the semiconductor material, the valence electron gains enough energy and breaks bonding with the parent atom. This breaking results in the formation of the free electrons. When the valence electron leaves the valence shell, an empty space is created inside the valence shell, which is also called as holes. Thus, both free electron and holes are generated as pairs. The mechanism of generating electron-hole pair by using light energy is known as inner photoelectric effect. The minority carriers in the depletion region experience force due to the depletion region electric field and the external electric field. For example, the free electron in the depletion region experiences repulsive and attracted force from negative and positive ions present at the edge of the depletion region. As a result, the free electron moves towards the N side. In the similar way, holes also move in the opposite direction. These electrons and holes are further attracted towards the terminals of the battery. The free electron reaches towards the positive terminal of the battery and the holes reach towards the negative terminal of the battery. And since free electrons are reaching to the positive terminal, which gives us the complete result that the current is start flowing in the photodiode. When no light is applied to the reverse bias photodiode, sometimes it carries a small reverse current due to external voltage. This small electric current under the absence of light is called as dark current. The dark current must be reduced to increase the sensitivity of the device. Also, we must know that the electric current flowing through a photodiode is directly proportional to the incident number of photons. Along with that, we should also know that the electric current generated in the photodiode due to the application of light is called as photocurrent. Some of the basic requirements of a photodetector are sensitivity, efficient conversion, fast response to operate at high frequencies, low noise, sufficient area, and low cost. The different materials used to construct photodiodes are silicon, germanium, gallium phosphide, indium gallium arsenide, etc. Now we will be discussing about the performance parameters of a photodiode. Now there are two basic performance matters, responsivity and quantum efficiency. Responsivity is the ratio of generated photocurrent to the incident light power. Quantum efficiency is defined as the ratio of number of electron-hole pairs generated to the incident photons. Now I will be showing you the PPT, which will be giving you a detailed explanation of how the photodiode exactly works.
Here we can see that this is the photodiode symbol, where the arrows represent the photons or the light energy which is coming inside the photodiode. So finally, this is the PN junction photodiode, where this is the P-type semiconductor and this side is the N-type semiconductor. In between is the depletion region. We can easily see that the P-type semiconductor is connected to the negative terminal of the battery and N-type semiconductor is connected to the positive terminal of the battery, which clearly tells us that the PN junction photodiode works under the principle of reverse biasing. Now, when the external light energy is supplied, and if this external light energy supplied is greater than the band gap of the semiconductor material, the valence electron breaks bond from the parent atom and results in the formation of the free electron. The empty space which is present in the valence shell is called as the hole. Now we know that due to the depletion region electric field and the external electric field, the free electrons move towards the N-type semiconductor and holes move towards the P-type semiconductor. They are further attracted towards the positive terminal of the battery and the holes are attracted towards the negative terminal of the battery. As we know that the free electrons are attracted toward the positive terminal of the battery, which clearly gives us the fact that the current starts flowing in the photodiode. The current which starts flowing in the photodiode is also called as the photocurrent. Now we should understand the fact that the photocurrent is directly proportional to the number of incident photons. That is, I is directly proportional to P. So I will be equal to Rp, where R is the proportionality constant and is also known as the photodiode responsivity. The photodiode responsivity is measured in amperes per watt. After deriving it, we get a direct formula which is R equal to Ne upon Np into E lambda upon Hc, where Ne upon Np is the ratio of number of electrons produced to the number of photons falling, which shows the efficiency of the semiconductor material. So we can finally write it as R equal to eta into E lambda upon Hc, where this formula tells us about the relation between the responsivity and quantum efficiency of a photodiode. So friends, this is all about the PN junction photodiode. Thank you so much.